Hello friends, welcome to the video. In my previous video I explained all the basic concepts and definitions of vector calculus. So today we shall see some of the problems related to the basic definitions. So let us go with the first definition, first problem. If f equals to xy square I plus 2x square yz minus 3yz square k, find divf, that is divergence of f at the point 1 minus 1 1. So here they are given a vector point function capital F and they are asking to find divergence of f, okay, at the point 1 minus 1 1. Here 1 minus 1 1 refers x value 1, y value minus 1 and z value 1. So we already know the direction, that is the definition of divergence of f. So divergence of f, the notation is del dot f. Okay. So then let us proceed with the solution. They are given a vector f equals to xy square I plus 2x square yz into j minus 3yz square into k. So let us take our definition. Divergence of f definition is del dot f equals to del means differential operator. It is given by I into dou by dou x plus j into dou by dou y plus k into dou by dou z dot. So our f is xy square into I plus 2x square yz into j minus 3yz square into k. So here let us rewrite this expression as del dot f equals to, here we can make three components because the given vector point function contains three components. The first component is f1 along x axis and f2 is along y axis and f3 is along z axis. So let us differentiate f1 with respect to x partially and f2 with respect to y partially and f3 with respect to z partially. So partial differentiation. So let's rewrite del dot f equals to dou by dou x of, here you just remember I dot I. So I, j, k are the unit vectors. I dot I value is 1. Similarly j dot j value is 1. K dot k value is 1. Therefore in next step you are writing dou by dou x of xy square. So xy square is your f1 plus dou by dou y of your f2 is 2x square yz plus dou by dou z of f3 is minus 3yz square. Okay. Then let's go for differentiation. Here xy square differentiation, partial differentiation of x gives 1 and y square you are treating as a constant, so therefore you are writing as it is. Okay. So differentiation of xy square gives only y square. Then similarly the second term 2x square yz, this term you are differentiating with respect to y partially. So therefore x square and z you are treating as a constant, so you are writing as it is 2x square z and differentiation of y gives 1. Similarly the third term minus 3yz square, here we are differentiating with respect to z. So z square differentiation gives 2z and minus 3y you are treating as a constant. Therefore, its a differentiation gives minus 6yz. Okay. So therefore, your dot product of a vector is y square. Okay. So dot product of the differential operator and the vector point function, it gives y square plus 2x square z minus 6yz. Now they are given a point, okay, del dot f value at a point 1 minus 1 1. It means x value 1, y value minus 1 and z value 1. Use these x, y, z values in your equation star. So then if you simplify, your final value del dot f value is 9. Okay. So therefore from this example we can understand always divergence of a vector point function gives a scalar point function. Here we got the answer 9 is a scalar. Okay. So divergence of a vector point function always gives a scalar, and curl of a vector point function always gives a vector. Okay, vector point function. Okay, let us go with the second example. Find divergence of f where f equals to r power n dot r, and also find the value of n if f is solenoidal. Okay, so we already know the solenoidal definition. So solenoidal definition is divergence of a vector is equals to 0. Means in this problem we need to find divergence of f value and the n value. Okay, here the expression contains r, so we know that small r indicates the position vector. Okay, so let's write the given expression f equals to r power n dot r, you take it as equation 1. Okay, then where r is the position vector and its definition is r equals to xi plus yj plus zk. This is the position vector definition, you need to remember. Okay, then we can write r equals to modulus of r bar, that is nothing but magnitude of a vector. We know the definition of magnitude of a vector, modulus of r equals to square root of x square plus y square plus z square. Means here you are finding the magnitude of the position vector r. Okay, then if you use if you square on both sides, then you are getting r square equals to square root of x square plus y square plus z square whole square. Okay, then square and root cancels, then r square equals to x square plus y square plus z square. You take this as equation 2. Okay, now you are differentiating equation 2 one time with respect to x, one time with respect to y, and one time with respect to z. So first let's differentiate with respect to x. Then left hand side r square differentiation gives 2r into dou r by dou x, and x square differentiation gives 2x. Okay, and y square differentiation is 0 and z square differentiation gives 0. Okay, therefore if you simplify this, if you take the expression for dou r by dou x, so equals to 2 cancels, you are getting x by r. You take this as equation 3. Similarly, the same equation 2 you differentiate with respect to y. Then left hand side same expression, 2r dou r by dou y equals to 2y. So 2 gets cancels, dou r by dou y value is y by r. You take it as equation 4. Then one time you differentiate finally with respect to z. Okay, then 2r into dou r by dou z equals to 2z. Here dou r by dou z expression is z by r. So now equation 3 is for expression for dou r by dou x, equation 4 is for dou r by dou y, and equation is 5 is for dou r by dou z. Okay, so then they are given a expression f equals to r power n dot r bar. So we know r bar definition, so let's substitute r power n dot. So r means its definition is xi plus yz plus zk. Then if you take its dot product, means if you combine, here you are getting f equals to r power n into xi plus r power n into yj plus r power n into zk. You take this as equation 6. Okay, then you take the definition of divergence of a vector. Okay, so divergence of a vector definition is del dot f equals to dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z, because we need to find the divergence of a vector. Okay, now del dot f equals to, so we got from equation 6 what is capital F. Okay, capital F contains 3 parts, that is the vector point function. Your f1 is r power n into x, f2 is r power n into y, and f3 is r power n into z. So let's rewrite this expression, dou by dou x of r power n into x plus dou by dou y of r power n into y plus dou by dou z of r power n into z. Let's differentiate first term with respect to x. Okay, For this you use product rule. You treat x as first function and r power n as second function. Then x as it is, r power n differentiation is n into r power n minus 1 into dou r by dou x plus r power n as it is, x differentiation gives 1. Okay, plus then r power n into y. Here also you differentiate in the same way. You treat y as a first function, r power n as a second function. Then y into n into r power n minus 1 into dou r by dou y plus r power n into y differentiation is 1. Okay, then last term you differentiate with respect to z. So it gives z into n r power n minus 1 into dou r by dou z plus r power n into 1. Now if you observe here, in all the terms x into r power n into r power n minus 1 is common. So here also n into r power n minus 1, here also n into r power n minus 1, n into r power n minus 1. So from all these three terms you take n into r power n minus 1 common. Then if you rewrite the above expression, then del dot f equals to, here if you combine these terms r power n and r power n, you are getting 3r power n plus. So from remaining expression you are taking n into r power n minus 1 common. Then the remaining terms x into dou r by dou x plus y into dou r by dou y plus z into dou r by dou z. So we know the value of dou r by dou x, dou r by dou y, dou r by dou z. So we got from equation 4, 5, 3, 4, 5. So equation 3 is for dou r by dou x expression, equation 4 is dou r by dou y expression, equation 5 is dou r by dou z expression. You just replace its expressions. Okay, then del dot f equals to 3r power n as it is. Okay, then n into r power n minus 1 you are writing as it is. Then x into, so dou r by dou x value is x by r from equation 3 and dou r by dou y value is y by r. Okay, then dou r by dou z value is z by r. Here you just go for simplification. In next step, del dot f equals to 3r power n plus n r power n minus 1. Here if you combine x into x, so it gives x square by r plus y square by r plus z square by r. Then here in denominator, r is the common term, you take r as LCM. Therefore del dot f equals to 3r power n plus n into r power n minus 1, x square plus y square plus z square divided by r. So then from equation 2 we know what is x square plus y square plus z square. So using the position vector we can write x square plus y square plus z square as r square. Okay, then here 1r gets cancels. Then in next step you are getting 3r power n plus n into r power n minus 1 dot r. Okay, then here r power n minus 1 and here r. So then if you combine these two, so you are getting n into r power n minus 1 plus 1. So minus 1 plus 1 gets cancels. You are getting del dot f equals to 3r power n plus n into r power n. Here in these two terms you take r power n common, then del dot f equals to 3 plus n into r power n. This is your divergence of a vector value. Okay, 3 plus n r power n. But here in this problem they are also asked to find n value, and to find n value they are given a hint. What is the hint? The given vector point function is solenoidal, means it is satisfying the solenoidal definition. So solenoidal definition is del dot f equals to 0. Then you got del dot f value, that is 3 plus n into r power n equals to 0. So you solve this, then here n value is 3. Okay, so this is the problem. So these type of problems they will ask for 2 marks. Okay, usually. So then the third problem I'll discuss in next video. Okay, so thank you for watching this.